Good morning, children. I welcome you all to the first online lecture on the topic circles, which is the 10th chapter in class 10th. Today is 17th of March 2020. Now, children, we all know what circles are. In this chapter, we are going to discuss about mainly three topics. First is the relationship between a line and a circle if they both lie on the same plane. By same plane I mean here, say on the same piece of paper as I am doing. So let us draw a circle. We know that to draw the circle first we need a fixed point, and with some fixed distance we draw a two-dimensional shape. Each point of the two-dimensional shape is at the equal distance from the fixed point O. The distance between O and the circle is known as radius and generally represented by R. Circle is written as C in bracket O comma R, where C stands for circle, O stands for center, and R stands for radius. So in future, beside writing circle, in few of the problems, I will be using this notation. Now, let us start with the topic. Let us draw a few lines on the same plane where our circle is. Now, what could be the relationship between these lines and the circle? Either the line will not touch the circle, or line will just touch the circle at a single point, or it will pierce through the circle. Like here, we can see that the three lines, namely L, L dash and L double dash are there. L dash touches the circle at point P, where P is known as point of contact, where L double dash pierces through the circle and touches the circle at 2 points Q and R. P is known as point of contact. Now, based on the points of intersection, their number, we decide the naming of these lines. The line which touches the circle at only one point is known as tangent, whereas the line which intersects the circle at 2 points is known as secant. In class 10th, our main focus will be on the tangent, its properties, and theorems which underline the relationship between circle and the line. Let us come to our first property. In this property, we are going to check that from a single point of contact, how many tangents are possible. So first of all, let us draw a tangent. We are given a circle with center O and we have drawn a tangent. Now we will slightly rotate this tangent, keeping the point P fixed. If we do so, we find that our tangent intersects the circle at one more point. Let us say this point is P dash. Similarly, if we rotate more, then another point of intersections come. Let us say P dash, double dash. Similarly, if we rotate on the other side, that is anti-clockwise direction, still we are getting one more point. So tangent not anymore remains a tangent. If we rotate it, it becomes a secant. This shows that at a point of contact, the tangent is unique and it is only one. This becomes the first property of the circle. Always remember, we are talking about a single point of contact. A circle may have infinite tangents at different point of contacts. So here we can see that these are the secants. And this secant has 2 points of intersection as P and P double dash. Therefore, the learning from this activity is that single point of contact implies a unique tangent. That is one and only one tangent. This becomes our one property of tangents, and which is a very important property. I hope you have understood this property well. Now children, always remember that at a single point of contact, one tangent. Now let us come to a theorem which says that it is given on page number 208 of your NCERT book, that at a point of contact, the tangent and the radius are always perpendicular to each other. The textbook statement is the tangent at any point of a circle is perpendicular to the radius through the point of contact. These three words, point of contact, is very important. To understand this, let us revise something from class 9th. Let us say you are going in a market and all of the sudden you find that a dog is chasing you and you are having 3 ways to run. First way, second way and third way. Let us say second way is perpendicular to the exit from where you can escape. Now which path you will choose? For obvious reasons, we can see that best escape way is way 2. This has been a theorem of class 9th also, which says that the shortest distance between a point and a line is the perpendicular line segment. Using this property, we will try to prove that the radius is the shortest distance between the center and the tangent. For that, let us first of all draw a circle. Let us say circle has the center O. Now make a tangent. Let the point of contact be B, A, P. So the point of contact will be point P. Let me inbox this area because it was only for understanding. Now we are given that APB line is a tangent, and we need to prove that the angle OPA is 90 degree, that is OP is perpendicular to AB. So before starting the proof, let us do a small construction. Join O and A. Now my task is to prove that OA is greater than OP. For this, let the distance OP, that is also the radius of the circle, as R. So in triangle OPA, let us say OP is equal to variable R, where R stands for the length of the radius. So we will say OP is R centimeters. Now because OQ is also the radius, so it will also become R, and OA is nothing but OQ plus QA. So it is R plus QA. It means OA is R plus something, which means R is same as OP. So our OA is definitely greater than OP. Similarly, we can prove OB is also greater than OP. OB is also greater than OP, which means that our OP is less than both OA as well as OB. So it is the shortest distance. And we know that the shortest distance has to be the perpendicular distance. So our angle OPA has to be 90 degree. Hence it is proved. I hope you have understood it well. If you have any query, please do WhatsApp me or join the Zoom session. My number is 97636167338. Best of luck for the first exercise. Please do it nicely.